Welcome to my video on solving practical inequality word problems. So we already learned steps for equation word problems. Now we're going to use those same steps to help us write inequality word problems. So recall, we first read the problem. Then we underline key words. Then we define the variable, and that means what is it that we are looking for. And then we write the inequality. This time we're writing an inequality instead of an equation. And then solve your inequality. And then, of course, analyze your answer. Does it make sense? Okay, so let's look at number 1. Daniel had $25 to spend at the fair. Underline. If the admission to the fair is $4, underline admission, $4, and the rides cost $150 each, what is the maximum number of rides Daniel can go on? So what is it that we want to know? We want to know the maximum amount of rides Daniel can go on. So let's say that R equals rides. So we know that Daniel had 25 to spend. And if we want to know the maximum number of rides that he can go on, then that is going to be less than or equal to, because maximum means the most he can go on. So he can't spend any more than 25, so he can spend 25 or less. Okay, now we have to put together the beginning. We know that the admission is $4 plus the rides cost $1.50 each. So that means I would multiply $1.50 times each ride. So I would write $1.50 R. So now circle your variable and draw your T, and make sure you're writing small because we don't have a lot of room to work with here. So we want to cancel out the 4 and get the letter by itself, so subtract 4 from both sides. The 4's cancel. Bring down your $1.50 R. Bring down your less than or equal symbol. And 25 minus 4 is 21. Now divide both sides by $1.50. The $1.50s cancel. And 21 divided by $1.50 is 14. So write R is less than or equal to 14. So circle R is less than or equal to 14. Now let's make sure we answer the question. So that's our inequality. What is the maximum number of rides Daniel can go on? He can go on 14 rides. So that's the most rides that he can go on. Okay, so your answer could be in inequality form, or it could be in a number form like this. So when we're solving these, we need to make sure we write both. Now, you were probably confused in the beginning because I think yours right here said greatest instead of maximum. So go ahead and cross out greatest here and put maximum maybe up here, maximum, so that you know we found the maximum and not the greatest. They mean the same thing, but I wanted to use the word maximum instead. So sorry about that. Okay, let's look at number 2. Blake must sell more than 20 ice cream cones. So underline more than 20 ice cream cones in order to make a profit. If he's already sold 6 cones, how many more ice cream cones does he need to sell to make a profit? So what is it that we want to know here? We want to know ice cream cones, right? So let's say C for cones. Okay, so we know that Blake must sell more than 20 ice cream cones. So that's the end result. We want to sell more than 20, so greater than 20. Now we need to figure out what goes on this side. So here's what we know. He's already sold 6 cones. So we want to know how many more cones does he need to sell. So we need to add the cones that he needs to sell to the 6 that he's already sold. So now let's circle our variable and draw our t. How do we cancel out 6? Good, we subtract 6 from both sides. The 6's cancel out and equal 0. Bring down your letter, bring down your symbol, and 20 minus 6 is 14. So C is greater than 14. But look, 14 is not the answer to this question. Here's why. It says, how many more ice cream cones does he need to sell to make a profit? He has to sell greater than 14. Well, 14 is not greater than 14, so I can't say 14. What would be one number greater than 14? Good, 15. So he has to sell 15 cones to make a profit. Because right here says he needs to sell greater than 14. Okay, let's move on to number 3. The 7th grade class is putting on a variety show to raise money. It costs $700 to rent the banquet hall they are going to use. If they charge $15 for each ticket, how many tickets, so underline how many tickets, do they need to sell in order to raise at least $1,000? Okay, so this one's a bit tricky. So what do we want to find here? It says how many tickets, so we want to find T equals tickets. You know what, better yet, let's call it N because T looks too much like a plus sign, so let's call it N equals tickets. And this is another reason we state the variable because then we can call it any letter we want. Okay, so we want to raise at least $1,000. That means greater than or equal to 1,000. Okay, now here's what we need to keep in mind. We want to make a profit. Okay, but we have to take the money we made and we have to pay $700 to rent the banquet hall. So this one's a little tricky to set up. He charged $15 for each ticket. So we take $15 multiplied by how many tickets, and we have to pay the $700. So we have to subtract the $700 from how much we make, and that will leave us with $1,000 or more. Okay? So circle your variable and draw your t. What's the opposite of subtracting 100? Good, adding 700. I said 100, but I meant 700, sorry. So cancel out the 700s. Bring down your 15n. And 1,000 plus 700 is 1,700. Now, what's the opposite of multiplication? Good, it's division. So we're going to divide both sides by 15. So divide by 15. The 15s will cancel. And n is greater than or equal to 113.3 repeating. Okay, now, guess what? You can't sell 0.3 of a ticket. So we have to sell greater than or equal to 113.3 repeating. Well, if we're going to sell at least $1,000 and we can't sell part of a ticket, we have to go to the next ticket. So what comes after 113.3 repeating? 114. So we have to sell 114 or more tickets because it said at least. So we have to sell 114 or more tickets to raise $1,000. And folks, what made this one so tricky is we had to subtract the $700 that we had to use to rent the banquet hall. Okay? And number 4, Lexi has 21 gallons of gas in her gas tank. So underline that. If she uses 3 gallons per hour, at most, how many hours can she travel before she runs out of gas? So we want to know how many hours. So H equals hours. And we want to go at most. How many? So we want to go less than or equal to 21. Okay? Because that's how many gallons Lexi has in her tank. Now, she uses 3 gallons per hour. So we're going to take the 3 gallons and multiply by how many hours? Okay, so the opposite of multiplication is division. So we're going to divide by 3. So H is less than or equal to 7. So at most, how many hours can she travel? 7 hours. She can travel 7 hours before she runs out of gas. Okay, so make sure when you solve these word problems on your own that you write an inequality, solve the inequality, and then make sure you answer the question that was asked. That concludes our notes on solving practical inequality word problems. I hope you have a great day.